Now using this prompter countdown clock instead of the overlay, so we don't really have to transition, throw any switches. Welcome again to the Information Philosopher. I'm Bob Doyle, webcasting from my ITV studio in Cambridge, Massachusetts. And I've lost my controls. See if I can do this. I'm hoping to reach philosophers and scientists around the world to help solve some great problems in philosophy, in physics, in biology, and in psychology. I also hope to reach any of you wondering about the deepest nature of reality and our place in the universe. We live in the information age, but I find that few philosophers or scientists understand the nature of information. An abstract quantity, I will claim, is the stuff of thought. Information is neither matter nor energy. Matter and energy are conserved quantities. It may be hard to believe, but the total amount of matter and energy in the universe today is the same as it was at the beginning of the universe, nearly 14 billion years ago. And if the stuff of the material world is just a fixed total amount, what can possibly explain all the evolutionary change that we see around us, the amazing new things under the sun? I'll explain those cosmological changes by showing that information and order in the universe have been increasing since the beginning of time. Change is the arrangement of the matter into what I call information structures, the galaxies, the stars, and the planets, for example. The stars are passive objects, though, under the complete control of physical forces like gravity. But living things, you and I, are structures under our own control. I'll show you that we are forms through which matter and energy continuously flow. And I'll show its information processing from the DNA in our cells to the thinking in our minds that controls those flows of matter and energy. Information is the modern spirit, the ghost in the machine, the mind in the body. It is our souls, and when we die, it's our information that perishes. Only our matter remains. So welcome again to my Information Philosopher lectures on philosophy, on physics, on biology, and on psychology that I will be presenting weekdays from 3 to 4 o'clock Eastern Standard Time from my studio here in Cambridge, where 60 years ago or 50-some years ago I earned my PhD in quantum physics, astrophysics at Harvard University. So today we have chosen to put up, let me just get you a link to my metaphysics website. Here we are. In addition to my Information Philosopher website, sometime last year I decided I would also study metaphysics. And the reason was somewhat complicated. I had for many years thought that metaphysics was a rather bizarre subject and detached in many ways from the physical sciences. Famously, at the beginning of the 20th century, there came a time, I'll try to get that metaphysicist website up on the screen behind me as we talk about it. And basically, I'm going to put the screen up just a little bit so you can see it a little bit better. There we are. Around the end of the 19th century, metaphysics was still a very popular subject in philosophy. But there came a time during the 19th century when the arguments of many philosophers who rejected metaphysical concepts decided that they would prefer to be arguing about only things that could be observable. And an observable was something you could actually go and measure. And many of the arguments about metaphysics seemed to be things that we only could speculate about. And philosophy came under criticism for thinking about things that can in no way be observed. Perhaps the most important one of those things that philosophers and then those special philosophers who came to call themselves positivists, where positive meant they would go out and only measure things that could be unseen in the universe. Positivists set this goal of only observables and thereby, for example, left out one very important thing, the human mind. The argument was, and it was a group of psychologists who came to be known as behaviorists, essentially denied the existence of a mind, arguing that it cannot be observed. What goes on in our mind, perhaps in our brains, is something that cannot be seen. And therefore they should focus on things like human behavior. If I raise my hand, they can see that, they can measure that, and they can do psychological analyses based on that. Behaviorism led mostly into the area of giving an individual person or an animal a reward for certain behaviors or a punishment if they did not do those behaviors. And then there was a schedule of reinforcing pleasures and non-reinforcing, discouraging pains, perhaps, in order to condition an animal or a human being into behaviors that were considered to be desirable if they had any kind of value judgment at all. A large number of people in the sciences thought that value-free experiments were the best form of experiments, that their work in sciences should not really have moral value overtones. That was considered somewhat of a moral dilemma. When I was an undergraduate at Brown University in the 50s, I was taught that science, generally speaking, physical sciences, but then in an extension, all sciences should have nothing to say about values. They should be value-free, and ethics was not a subject for philosophy. It was a subject for physics, or science in general. Ethics was a subject for philosophy and or perhaps religion, where the great traditions in most religions taught their believers the difference between good and evil and so forth. So there came a time, and especially strong in the 1920s, when the so-called Vienna Circle arose in Europe, and the members of that circle argued strenuously that they should avoid anything that could not be observed in the material world. And so there came to be an identification of sciences, the unified sciences, all of them together, as having only physical, but they meant material, observable things going on. Anything else was regarded as metaphysics. Some members of the Vienna Circle used to shout, wave a hand when any speaker said anything that sounded vaguely metaphysical. That got to be so boring, they were told they could only say M, whenever they heard something that seemed to be metaphysical. So for the rest of the 20th century, metaphysics came to be sort of a pariah. It still was taught in philosophy departments, but there it was taught as the history of philosophy, the history of metaphysics in philosophy, because metaphysics famously begins with an editor of the great works of Aristotle, organized them into books. And the books tended to be in an arrangement in which those lectures which were on what Aristotle called first principles, and those first principles were difficult subjects, for example, the nature of being as opposed to becoming. Famously, Aristotle's teacher Plato had argued that the forms, the truth in the forms, the goodness and beauty in the formal ideas, he called them ideas, and he declared them to be more real than the everyday world, which was a poor imitation of these perfect ideas, like the notion of the perfect triangle. So Aristotle came to doubt that Plato was right about the reality of these pure ideas, a kind of idealism in modern terms, and Aristotle leaned toward looking at the world as it is. We could call that the material world, and that introduced a great dualism between idealism on the one hand and materialism on the other. And so even from ancient times, metaphysics turned out to be the name that this editor of Aristotle's works gave to those lectures by Aristotle on issues like being itself and, importantly, issues of the beginning of the universe, or did the universe have a beginning, or did it exist forever, which was more suitable for being a kind of a truth, which was time independent. The notion then and now is that truths surely do not depend on the time. A truth should be a truth for all time. It's outside of time, and that came to be through the centuries a characteristic of philosophy, that it was trying to reach truths that were somehow outside of time, outside of space and time, especially prominent in the work of Immanuel Kant, who thought that the phenomenal world was that material world of observable things which Aristotle started us off on. And then in Kant's thinking, he postulated an additional world, the phenomenal world describing the world we live in, and then a noumenal world which is above that world. And he called it the place where we would find those issues like God, freedom, immortality, famously. But they were touching on pure ideas also. And I think, although Kant didn't stress this strongly, he was working in a tradition that was after René Descartes, who had been the first modern philosopher who tried to deal with questions that were, since Aristotle's time and all the medieval scholastics, a question of origins of things, the world, and the mind in particular, as something that seems to be above the material world. Descartes famously defined the mind-body problem as we have a mind, he thought, that was not material. Thoughts, he thought, were immaterial. But how could an immaterial mind with no physical, there could be a physical presence, as we'll see in the work of information philosophy, but there's no material presence. And so how could thoughts, if they had no materialism, no matter to them, push on a material object and make it move? And that was a famous puzzle. He decided there might be a tiny element in the center of the brain where there was a pineal gland through which the immaterial mind could push somehow, quite illogically really, on the material brain. So the mind-body problem was faced by Kant, and he argued there was above the phenomenal world a realm, and maybe that's what's going on primarily in that realm, was investigations of things like free will, as if the physical world couldn't contain freedom, and he was following his understanding, Kant was following his understanding of the laws of nature, since Isaac Newton's laws seem to describe perfectly accurately everything that goes on in the material world. And it was suggestive that everything, every event followed from an earlier cause that caused the event, and the earlier event had in turn its causes, and these causes went back in an infinite chain to the beginning of the universe, which was one of those questions that Aristotle declared to be metaphysical. So the philosophers of Europe, Kant and then Hegel and then Marx, who took the Hegelian ideas and pushed them into an extreme materialism. Hegel had been a very strong idealist philosopher, thinking that he was explaining that there was an absolute idea, a Platonic level, Kantian noumenal level, which somehow was guiding the world and guiding it towards better and better social systems, philosophical systems in Hegel's mind. But Marx just said he found Hegel was standing on his head and trying to make the base of all the world be the Hegelian absolute idea, the Geist in German, that the spirit was somehow in charge of what went on in the material world. And Marx wanted to turn Hegel upside down and get him right side up, and notice that when Hegel walks around, he has his feet on the ground, and when he thinks things, those are the things that are up above. Some critics of Hegel and critics in general of the German idealist philosophers was that when Hegel and others start to talk about ideas, they go floating up in a balloon somehow, and everything they're doing is somehow up in that noumenal realm of Immanuel Kant. But when we get to the end of the 19th century, all of this floating up stuff was thought to be just ideas and therefore having no power to influence the world. Well, it's strange because it's not commonsensical to think that our ideas have no influence on the world. You know, some say ideas can move mountains, and individuals with great thoughts have found ways to convince many others to follow their ideas and then become more and more powerful in the world, creating a great culture, creating a great nation, creating a religion. And those ideas are the glue that holds that whole organization together. In the world today, we have many such groups, some of them causing a great deal of problem for other groups who think their ideas are more true, if anything, or the absolute truth, whereas those not following and being a good disciple of a certain belief system can often be annoyed at and causing great difficulties for people with different points of view. So, at any rate, in the early 20th century, behaviorists and the positivists, the logical positivists, Bertrand Russell and his young student Ludwig Wittgenstein argued for eliminating metaphysics. And that led us to a paucity of work in metaphysics, as I said, except for that which went on in universities where academics taught the history of philosophy and taught us about the history of metaphysics. So my work in information philosophy, which, as you know in my past lectures, has tried to cover the great problems of philosophy and physics, I looked into books about problems. And let me switch to my overhead camera here and take a look at the back of this book. What I did was survey popular textbooks and websites on philosophy. This survey produced a remarkable consensus on the great problems, starting with books like Bertrand Russell's Problems of Philosophy. And one of the first things they always began with was things like metaphysics. The problem of knowledge. How do we know what exists in the world, and the mind-body problem? And so my book, Great Problems, began with thinking about metaphysics. Let's see if I can find a picture of my taxonomy. I think I need to back up a little bit for you to see this. So let's go to 4 maybe. No, that's too far out. Let's go to 6 maybe. No, let's go to 7. Very good. I now have some significant control over that camera, which I didn't have in past lectures. And here I want to show you that my arrangement of all the problems in philosophy and physics, then a certain amount of biology and psychology will be coming in, especially in the mind area. I found work should begin with metaphysics. And I wrote a significant chapter on metaphysics. Here is the metaphysics chapter. I think you can see that heading. And I wrote quite a few words about it, took it very seriously. But then there came a time when I thought, I've got to do a lot more. And so my third book is just devoted to metaphysics. And that's where we want to begin this lecture today. So let's back up here. Now, it would be best, in order to give you some sort of deep insights into a particular problem, I thought if I just picked one of the problems in metaphysics, of which there are many. Here, let me just expand this view where I try to list them all. And let's go into looking at that screen here. I basically, well, you can see, look at a great number of problems. Abstract entities sounds very abstract, and indeed it is, and it gets to the concept of information as I see it, an abstract quantity if ever there was one, pure information. Being and becoming are the problems that Aristotle faced right at the get-go over 2,000 years ago. They still remain rather important problems. Causality is a problem because modern quantum physics has introduced the idea that maybe there are non-caused causes. That is to say, a non-caused event, an event that came about not because it was determined to come about because of a causal law, but it came about only statistically, accidentally perhaps, involving chance, which is the next thing that is a very profound question in metaphysics. Then change. Those who believe that the great truths of the world remain constant also would like to think that everything is constant. Physicists like to argue that, and correctly, there is no change in the total amount of matter and energy in the universe. Those quantities, matter and energy, they're variations of the same thing according to the work of Einstein, who's related the two with this famous equation E equals mc squared. So matter can be converted into energy by multiplying by the velocity of light squared. You get an enormous number, and that was Einstein's prediction of the existence of today nuclear energy. Now there are many others here, and I think we can just skip down them a ways. God and immortality were those problems that Kant thought was going to be solved by thinking about a noumenal realm, that is a phenomenal and immaterial realm. The mind-body problem we've been touching on before, but coming down to the end, the problem of wave-particle duality is the one I thought we would focus on today, because it's a nice transition into the work of Albert Einstein that we're going to be doing every Friday. Let me see if I can actually put this up and put this one on. Maybe I can't. Oh, yes, I can. Just wanted to show you that our schedule of lectures will be every Monday will be on great problems, and there's some overlap there with problems like free will. On Wednesday, we'll focus on one or more philosophers out of my list of 200 philosophers and 100 scientists on the Information Philosopher website. Here we are Thursday with metaphysics, and on Fridays we'll be doing Albert Einstein. Whoops, I've got to learn to turn that off and come back to this. I'm still not having a great deal of precise work with my tools that I've designed. This studio I'm sitting in, I designed completely myself and built versions of it that were in a suitcase that I've given to schools and or organizations around to try to create programming with multiple cameras to go on the internet. This is one of my latest initially entrepreneurial goal. I thought I might work with my grandson to provide these kinds of tools to schools mostly, but any young or group of people who would like to produce an internet television program. That's why I call my studio the ITV studio. Let me show you a little bit around the studio for just a moment. Let's first go here, and I want to be on this view. You see what I have in front of me is a set of screens, actually several of them. I guess we see 7 screens right here. And I can zoom in a little bit and go to this screen to see I've got my screen with the metaphysics on it right here. Over to my right, I have a screen with the wave-particle duality, which we're going to come to. Let me show you what that looks like. And in the middle, coming back to this screen, I have a switching surface. Let's see if I can get a little closer to that. There's my surface with the metaphysics page. Here's my switcher, which allows me to change from one camera to another camera. If I was to press the button 3 here, we'd lose this screen, and we would go to my screen from which we just came. And I'm going to touch. Let me just look overhead for a moment and zoom back in this view. Here we are, looking down at the same situation that I've built. Here's my screen with the Metaphysicist website. Here's a page on wave-particle duality. Here's my switcher, which I can select any one of 7 cameras. Here's my keyboard that I use to drive around on one of these. Let me go back to screen 1 and see if I can take us to a view. Let's see, here is the right-hand screen, and off to the right here, you may be able to see just somewhat. Let me just move to the right a little bit, and if you look closely, you'll see my voice going up and down here in my sound levels meter, so that I know when music plays and I'm talking, I'm able to balance all of those things. Let's look from the other end of the room for just a moment. And you'll see I'm sitting in this rather large studio, and I have a great number of screens that allows me to do several things. Let me go to zoom in just a little bit. So I have these tools in front of me here. Off to my left, I have a screen which shows all of the individual cameras. Let me see if I can bring that up. I'm not sure I can, actually. I'd like to show you that. I can perhaps zoom in a little more closely. Let's try this. There we go. So now you can see my own picture here and each of the other cameras. One camera, for example, is here, number 8. It's just got the overlay that I just put on top of me as we looked at the schedule of my lectures from Monday, Tuesday through Friday. I think I'll show you around a little bit more here by just, let's see, 5. Behind my head, I have a countdown clock reading 28 minutes, 17 seconds into the program. And if you look closely below that, you'll see that I can scroll the text of my introductory material, where this is called a prompter program. And I've designed and built that prompter, which is actually an extremely low-cost prompter. Everything I do, I try to make tools as inexpensive as possible. So there we have my multi-view screen. Now over my head is showing the program. It's exactly what I'm showing up on that program screen. And underneath that program screen is a camera. This black fellow here is a little camera. It's camera number 1. And when I move camera number 1, well, you really can't see it. It's like a little telescope dome, and it turns and it moves in and it zooms in and out. It's a beautiful little camera. Up here I have a screen which is the screen that shows the metaphysicist at the moment. And I have 2 of those screens. Let me just move a little bit along here. Come on, number 7, 6. I have 2 of those screens. Now you can see there the 2 bright screens on either side of the large screen. The large screen in the middle I can convert to show different things. For example, I can put my multi-view, which is down here on my desk, but there it is up there. And you can see all the different cameras. From that position, let me just zoom in a little bit to show you that this multi-view. You see we have a little bit of a picture-in-picture video feedback situation. Let's see if I can get it down and sort of in the middle. And if I zoom in, you can see all the cameras are doing something different. So let's get back to me. And now I've got multi-view on the whiteboard screen behind me. This is the thing I'd like you to understand what I'm doing. I not only want to teach people philosophy and physics, but I also want to build tools. In the past, I've built successfully some interesting tools. As soon as I graduated from Harvard, my wife Holly got a PhD in the same field, astrophysics, quantum mechanics, that I did. In those days, we had anti-nepotism rules, which prevented the 2 of us from getting a job at the same university. Today, universities work hard to find work for a spouse. When they want to attract a scholar, they also work hard to make sure the family stays together. That wasn't the case in the 1960s. I had married friends who went off, and one went to UPenn and the other to Johns Hopkins, and they tried to commute on the weekends and stay together, but that marriage fell apart, and I didn't want that to happen. I told Holly, I'll invent some things, and maybe we'll make enough money to stay right here in Cambridge, which we did, and I did, and so here we are, many years later. And so the first tool I built was to allow people to make films, synchronizing sound with little Super 8 consumer movie cameras. And ever since, I've been trying to help communities figure out how to communicate. And today, I'm using tools that I've built through the years to provide those to others. But now, at 81 years old, I've decided I will just use these tools, building them into this room where I can sit and connect to the internet rather easily and present my lectures. I faced the great challenge of making these lectures, what shall I say, taggable, findable, by putting enough information in them. And I'm going to use a blog, a kind of tool which is a chronological timeline, to put one lecture after the other in a time sequence, and also use tags or maybe hashtags that can be used to kind of help people find work on different subjects. And the subject for today is metaphysics. So let's go back to this screen, and we'll see a bit more about wave-particle duality. Let me just switch to this screen, and here is the subject of wave-particle duality. Now, in physics, the question is, can something possibly be at one and the same time both a discrete particle? Okay, let me just go over here for a moment and get this one up here for me. Can it be both a discrete particle, which is what Werner Heisenberg specialized in discovering the physics of particles in what was called his matrix mechanics, a rather abstract name, but he had a focus definitely on the idea of the dynamics of a particle. And can it be at the same time a continuous wave? Now, the wave mechanics was a competing view to Heisenberg's matrix mechanics developed by Erwin Schrödinger of the famous Schrödinger's cat experiment. Now, my interpretation of quantum mechanics says unequivocally No, because it is all, I like to argue, it is always either a wave or a particle depending on how you look at it. Now, this has become a little more sophisticated these days because the equations that describe the evolution of a quantum system, like an electron or a photon, tends to be thought about in two stages, similar to my two-stage model of free will, if you notice. The first is a wave stage in which the wave function moves around in space, giving us values at different places and different times. And those, what it gives us is the possibilities that are available of finding a particle at one of the places where the wave is evolving. Notice, therefore, that the wave is nothing but possibilities, or specifically probabilities, that, given the physical surroundings, the apparatus, the experiment, or whatever you're doing, those walls give us what are called the boundary conditions for solving the Schrödinger wave equation. Now, because, okay, I'll go back away from this just a moment, come back to myself, and rather than reading what's on this page, which, by the way, is a rather old page, and I have a rather more sophisticated view of some of this in my book on metaphysics. Try to turn to that and see if there's something we might like there. Today, we can connect waves and particles where the wave is considered to be just a probability. Now, probability is a mathematical quantity and very abstract. I'd like to say, considering what we've just been saying earlier about the distinction between the mind and the body, or the distinction between the Kantian noumenal world and the phenomenal world, that the wave is simply carrying information. Now, abstract information about where a material particle will be found statistically. So, it seems subtle, although I'm getting more and more confident in saying that the wave is just an idea. It turns out to be information. It's not just a random idea that we're having, that the physical experimenter is having, because the Schrödinger equation, a mathematical equation, is giving us definite numbers about where particles are likely to be found. And when we send one particle through space and it lands somewhere, we cannot say where it will land, because it is only statistical knowledge that we have in the wave function. But when we do many experiments, thousands of experiments, indeed we can do very large numbers of experiments, then we'll get a distribution of particles in different places that precisely, and more precisely as we do more and more experiments, correspond to the theoretical prediction of where particles will be found. So notice, not just a kind of abstract mind-like, information-like level in the wave, and a material-like, matter-like particle on when the experiment is completed, but we can go and notice that these two aspects of wave and particle duality correspond in a real way to the difference between an ideal and material. So we have immaterial and material. We have ideas and thoughts about what's going to happen, and then we get experiments. Now those ideas, the Schrödinger equation of quantum mechanics, is fundamentally a theory, whereas the measurements that we do to try to confirm that theory are experiments. So this duality, which is called the wave-particle duality, I'd like to argue, and I hope when you hear this examined in many other lectures, you'll come to accept, as I do, that there have been dualisms for all time. There's a wonderful history of all kinds of dualisms, but they all may be brought back to this dualism that began at the beginning of philosophy, when metaphysicists like Aristotle wondered about the realm of Platonic ideas as opposed to the everyday world, which was associated with change and becoming. So again, the Platonic ideal world seemed to be the home of eternal truths, and the phenomenal material world seemed to be changing and ephemeral, not eternal. So again, the ideal world, it really is not unchanging, but the old theory about it was that it was eternal, unchanging, and there was the home of being, or what Heidegger and the existentialists, later Nietzsche and so forth, called the essence of anything at all, was like a Platonic ideal, and the existence of such an instance of one of these ideal things was thought to have becoming. And so we have books like Sartre's Being and Time. The title is slightly off from Being and Becoming, but if you look closely or think about it for just a few minutes, you'll see that being and time correspond to the eternal nature of the Platonic ideals and the ephemeral or changing nature of becoming. So being and becoming can be seen as being and time, because time seems to exist in this material world of becoming, whereas, going back to Kant again, the phenomenal world is a world of change, following laws, all determined. But Kant's noumenal world is a world in which there are these perhaps eternal truths, as Plato had thought, although what Kant put there was God, freedom, and immortality. Well, those are rather difficult things to picture if we have no time there. There are arguments that God is outside of time. Theologians talk about this a lot. They think that God has a omniscient, God's eye view of all time, past, present, and future. And immortality may, if it existed, be a state in which there's no change, which doesn't sound very pleasant, but we'll look at some of those particulars in future lectures. But what do we have today? Let me take you to a page, if I can quickly find it. I don't see a quick reference to it right here, but because it's a dualism, we should be able to find it. Let's take advantage of my website search capability. I'd like you all to know that everything I'm doing is just found in my website, and much of it found in my books, of course. So I've entered dualisms, and let's just go there for a moment. And here we find, let's close this keyboard, we find dualisms. And a big example, of course, is the mind-body problem, which we see here at the bottom. But what I'd like to do is go into dualisms and expand this. And I'd like to show you, you probably know this, that many philosophers have seen this fundamental dualism. Although there are said to be philosophers, I mentioned in the second paragraph here, that many have claimed to be monists, which is to say those who say everything is one. So I'm going to go on this website right here and get my information philosopher. Give me a moment. What I'd like to do is be able to show you where my mouse is moving around. So I'm opening up another. I'll show you what I'm doing by going here. And so I'm typing into this. This screen is the Surface Pro, and when I touch it, you can't see anything on its output about where my mouse is, because it doesn't have a mouse. And let me just back up here a minute to maybe this one. No, that's too far back. How about this one? One more right here. So on this screen, I brought up the information philosopher, and then I'm typing into this search bar the word dualisms. Let's add an S and say go. And let me switch to that screen, which should be here. And here I found dualisms. I'll click again on dualisms, and I'll increase the size of this as much as I can. And then you'll see my mouse is here now. I just wanted to point out, now I can show to you that a monist is someone who argues all is one. And they generally, monists, had to say either the world is just one thing, one substance, or and in which case they had to choose the so-called substance of what it is they were choosing as either the material world, which some would call the physical world, or the ideal world. And so right from the get-go, anyone who said they chose one side of the dualism between the material and the ideal were themselves admitting there was another side, but they preferred to believe in only one of them. Now, I have some quotes here. The best one I like is Charles Sanders Peirce's version of Kant, who is in German. I'll leave him behind. The variation of this idea of Kant was that if materialism with no idealism is blind, idealism without materialism is void. There's nothing in it. You see the kind of, I'm looking for the word, the interdependence of the concept of ideas and the concept of matter. You can't have a concept, as I now rewrite this, without a perception. If you had a concept and it had you couldn't see anything corresponding to it, it's like there's nothing there. But a perception without a concept is said, I call it blind, adopting this blind idea from Kant, and that is often said that we can't really see anything looking into the world unless we already have a conceptual notion of what it is we're seeing. So anyway, I just want to zip by some of these modern things to show you my sense of the multiple names through the ages for dualisms, okay? And the idea difference between a monism that everything is one, and then a view that no, actually there are many things in the world. This was an argument that went on for some time, in ancient times right down to modern times. William James, his famous pluralist, argued for the fact that there are many different things going on in the world. And here's my major name for the big dualism, idealism versus materialism. My work in information is to say that information is an idea. That is to say, it describes the arrangement or the pattern, the structure, the shape, which tells us something contains information as apart from the matter in which these patterns are embodied. And so it goes on. Plato famously had a divided line in which theories were on one side and then techniques, which we could think of as experiment, were on the other. The words eternal and ephemeral we'll find again and again, especially in some religious analyses. The notion of the essence of something as opposed to its mere existence. And this dualism of essence and existence featured prominently in the work of Martin Heidegger, who is seriously a metaphysicist in many ways. He called I guess Nietzsche had referred to himself as the last metaphysicist, or the last metaphysician, which is the more common word for my word, metaphysicist. I like to think that I'm a metaphysicist because I'm very interested in the physical implications of metaphysics, whereas the metaphysicians are generally more interested in the philosophical implications. So at any rate, when I was an undergraduate at Brown, one of my philosophy courses was on existentialism, and you can sort of see the difference between the existentialists like Nietzsche and before him, perhaps Marx, as contrasted to the essentialists like Hegel and back to Plato, who think that the essence comes first and then the world comes into existence. Essences are things that, say, God knows about, but the particular existences depend on the real world. Plato called his world of ideas real, but that was a different use from what we have for reals. So when Nietzsche argued, no, we are in the world, fallen into the world, as Heidegger calls it, and we exist before we figure out what our essence is. In other words, if you didn't have human beings or beings of any kind, you wouldn't have any thinking about the essence. Those who want to have essence before existence are happy with the idea of a great sort of creative force, perhaps an agent who has preceded everything here. And the existentialists tend to be materialists who think that the world came first, and then thinkers figured out what the essences of all the things are in the world. So this goes on for ages. These are sort of scholastic time periods, and I think I won't try to talk to you about any of those in particular. Here's Kant's Transcendental Critique, it's called, in which he made a distinction between his noumena on that side, an ideal side, and his phenomena, the phenomenal world. Here's two variations of ways of thinking about Hegel and Marx, and the notion of a supernaturalism versus a naturalism is an important one. The linguists also had their own way of thinking about these things, the difference between a formal ideal language and an ordinary language, and so it goes. So we've gone rather deeply into this situation of dualisms, which is one of those great fundamental metaphysical questions. But I think I want to come back to a picture of waves and particles that I have here. Spend a few minutes on that before our time runs out today, because it's a very specific example of a metaphysical story, which is also a physical story. So this is what's called the Twoslit Experiment. We talked about how the wave is related to the particle, and this is one of the great experiments to see the difference between a wave and a particle. So I guess I'll open this one also over on the other page and go back to this page for a moment, because once again I can work with my mouse and we can drive around in it a little bit. When Newton thought about light back in the 16th century time frame, he imagined that light might consist of little particles flying around. But in the Thomas Young work of 1802, Young studied the motion of waves, especially waves that are traveling through two slits in a wall. So he drew this as his exact drawing of waves interfering with one another. The letter A here, let's see if I can push this up. I probably can't make it any larger. A is a hole in a little wall, and B is another hole, and D is the distance between those two. And when water comes through both A and B, you get these little circles of expanding waves traveling away from A and some traveling away from B, and they interfere with one another. So what they tend to do is create places where you can see there's a heavier, higher crests where two waves, one from A and one from B, come to a point at the same time, and other places, the white areas, where they're out of step with one another, and so the crest in a wave from A matches with a trough in a wave from B, and there's no wave at all. So it was this notion that light also could be waves, which led to experiments that studied these patterns of interference between waves. And we've been able to see this by having light shining on a very, very thin, tiny slit. The size of the wavelength of light means it's a very tiny slit. And we saw this interference all the time. I'm going to just jump forward over a lot of my work here. Next time, I guess next Thursday perhaps, we'll come back to Richard Feynman's discussion of the waves, particles in the two-slit experiment in his lectures 40 or more years ago. It was very interesting. But I'm just going to zoom down among the various ways of thinking about it. Here's a picture of what Young had found. Here are the waves coming from one slit and these waves from the other. And you can see that they combine to be very strong in the middle and then have these bands of light and dark where there's interference. So what I want to do here is make an animation. Let me shrink it down a little bit so we can see it a bit better. And now imagine that we have only one slit open for the starters, and we see this pattern on the back wall. Whoops, I've switched to two slits open, and now they're interacting with one another, and they're heading towards the picture when there's only one slit open. We may need a few more minutes to take into effect what's happening here, but the argument is that when the two slits are open, we have one pattern, and it shows this interference with the 5 bumps primarily. When there's only one slit open, we see a very different picture. I should arrange the timing of this little picture so you can see it a bit better. What I see as going on here, and it's a rather difficult thing just to talk you through it, is that when the two slits are open, the interference occurs. Now when there's only one slit open, it's a very different pattern of interference with only one major bump in the middle. And this is telling us that if we send lots and lots of particles down with only one slit open, we're going to get one picture, the one that's coming into focus right now. Whereas if we have two slits open, it's a quite different look. Now, the central notion is that particles are sent down one at a time, and there's only one inside the experiment at a time, and yet when we make 1,000 measurements, let 1,000 particles come through, we see this interference. And the metaphysical problem behind it comes from, how can it possibly be that if a particle goes through the right-hand slit, it interferes with itself so as to produce this pattern of interference? And what I'm going to argue when we go into this in considerably more detail in the future is that it's not the case that the particle interferes with itself. It's the case that because the two slits are open, the Schrödinger equation solves for the probability of where there will be found, and even though an individual particle always only goes through one slit, it obeys the probability rules that we can derive from Schrödinger's equation to say where they will land on the back wall statistically, and sure enough they do. And my argument is that the information about the interference lies in the fact of whether the two slits are open or only one slit is open. I'll say that one more time. If there are two slits open, the Schrödinger equation produces this picture of interference, whereas if there's only one slit open, it produces this picture of interference. So we have talked a bit about metaphysics, and I look forward tomorrow to talking to you something about the work of Albert Einstein. We'll be looking at him through this picture. Let's go here. This book has about 16 or 17 chapters written. Like all of my work, it's freely available in PDFs on my website, informationphilosopher.com. I encourage you to go there, and if you're interested in Einstein and what we're going to be learning about him in the many lectures that lie ahead of us. So, again, thank you very much for watching, and look forward to seeing you again tomorrow, Friday.